Okay, here's the second one, and now you'll see why I recommend putting all Q's together first. So here we have 25.5 grams silver ring at initial temperature of 84 degrees Celsius that is put into 0.05 kilograms of water at 24 degrees Celsius to begin with. They give us the CP for silver, we know the CP for water, and unlike the previous problem, we have Q that is lost. So water sample. So what is happening here is that there is where's our, there you go. There is Q that is going straight into water, but not all the Q that came out of the sample went just into water. Some of it went into the environment. In other words, some of it was lost to something else and not to water. So we have 3 Q's altogether. So energy loss means there is an extra Q, but they still all add up to 0. So I can say that Q of water, which is going to be positive, so I can mark this as positive. Q of silver, which is negative, and Q of loss. And here's the thing, Q of loss is lost to the silver, but it's a gain to everything else. So another way that you can think about it, so you have your sample for whom Q is negative, and then you have everything else that gains from it, so it's water, and then there is the environment, which they dubbed as Q lost. So this negative Q right here, the Q lost by the silver, equals Q gained by the water and Q gained by their environment. But just let's keep it the way it is. So all Q's add up to 0. So if you open the bracket, if you rewrite what Q's are, you will have the good old CP mass changing temperature, CP mass changing temperature. And the way they gave you that loss was 0.140 kilojoules, which will be 140 joules. So here's our long formula. Now we're going to distribute. Okay, we just multiplied everything. That factor by T final, that factor by initial, that factor by T final, that factor by initial. And then again, I will color code this. And so this is final, and this is everything that is not multiplied by T final, right? So as before, what we're going to do, we're going to take this, which was negative, will become positive. This, which was negative, will become positive, and this, which was positive and will become negative. All of these will go on the other side of the equation sign, right? And then I will factor everything that is multiplied by T final, which is this, and I will put those both in the parentheses, and they're both positive. So hence we end up with T final multiplied by these two equals, these two were negative, now they're positive, and 140 was positive, now it becomes negative. So I'm looking for T final that makes this big fraction, and then I just go ahead and put all the numbers in, and that will give you 25 degrees Celsius as the answer. And there you go.